Hello. Does this work? Yes, it is working. Hello. I'm gonna finish all of LeetCode easy. If you ask me why, I don't know. I'm just really bored, and I hate doing LeetCode. So I think this is a good thing to do for some reason. Yeah. Give me a second. I need to change my Twitch. Oh, I need to start it. Okay. I'm gonna change it so that edit. Alright. This is either gonna be really fun or really stupid. Probably really stupid. Let me share my screen. Okay, cut. Alright, I searched it up. There's 828 easy questions. There's 17 pages of 50. This is like about like half 30. So that's 16 times 50. Here, I'll use 16 times 50. Yeah, it's about 830. Yeah. If I do it all one question, and let's just keep doing it, and I can figure out the rate. I already saw some of them. What code? I don't know. There. Yeah, sure. Okay. I haven't done LeetCode in so long. I guess I'll change it up. I'll do C++ first, and then when I get bored, I'll do other programming. I'm gonna try to do... Yes, see, some of them I solved like 4 or 5 years ago. Maybe 4 years ago. When I actually wanted to do LeetCode. Now I'm just gonna do it. I have a vector of type int and vector address nums int target. Such that they add up to target. So I just go through the nums and then go through every possibility to figure out what the number is. So how do I get the length of dot size? Plus, and then we'll do another one, and then we can probably do sliding window or something, and we'll do this until if nums of I plus nums at j is equal to target, then return. Wait, how to get value of vector dot at. Okay, I'll just do that. Then we return 0 and 1. So return new vector int nums at I, nums at j. How to make vector. vector name. Oh, I probably don't want new because it's not static. Vector int vec. Okay. Apparently this should work. Okay, run. Let's see. Did we do it? No. Maybe I just will use pushback. Push back nums at I. Pushback nums at j. Nums at I. Maybe I can't do it because it's trying to find the value at the address. std out of range, nums dot size. Should give me like 4. So. Oh, I didn't. Okay, thank you. Plus 1 probably. What? I'm confused. Two, 7, 11, 15. Oh, the index. Okay. Now we can try. Nice. Okay. Let's submit. I want to try to do it most efficiently. Runtime beats 5%. Hey, but my memory's going crazy. Okay, let's figure out some ways we can make this faster. So we can do this, which is brute force, or we can... Oh my god, this is so slow. What else can we do? One and two. Yeah, we can use sliding window, I think. I just don't never use sliding window. This is gonna be my life now. Left and right pointer. Find the side. Bro, I can't see anything. Max sum. Hey, that's what I did, the naive approach. Current sum, window sum. Initial phase wave calculated. 6. Oh, I get it. So you include this space, so 2 plus 2 plus 7, 9, 20, plus 7 plus 23, 30. Huh. Move on to sequence before. This guy has nice examples. And 21. I don't see how this could work for this. Okay. Start and end to mark the starting and ending of the window. I see. Okay, so we can do So like for this approach, we'd add 3 plus 2, but it's less than. We add one more. Okay, let's do that. So 4. Add. We need the new vector. We need a new vector. Temp window. Then we go through nums dot nums at I. So we want to add and see if we don't even need template, we just need total sum plus equal pause at I. If total sum is less than pause, we actually don't do anything. If it's greater than, so if we do 2 plus 7, that's fine. If pause equal 9, then so in this case it would be like 9. If total sum is greater than 9, you went too far. So you have to subtract the last. Push back. Nums at I, so this would be like 2, for example. Else. Print. Else we don't do anything. We just keep waiting. Else if total sum is equal to nums. Dot erase. Then we're going to pause that erase. So erase the first one because it's too high. So like for example, 3 plus 2 plus 4. The first one is too high. Okay, I'm back. Oops. I got a good call. I had to take. Anyways, I'm still doing this question. It's been like an hour. Or 30 minutes. Let me do. Push back, pause, push back. Sum, total sum equal nums. Total sum is equal to target. Then return, pause. Okay, I think that should work. But let's say I have array 2, 4, 6, 8. Or sorry, 2 and 4 and 10. 2, 6, and 10, and the target is equal to 10. So the first number I have is 2. My total sum is 2. Then we have array of 2 and the position. It's not greater than nums, it's not equal to the target, so we return. Okay, we have 4, 2 and 4. Is this greater than equal total sum is 6? It's not. We go back up. Alright, cool. So we add 16. We push back temp values, so there's 10 here. There's 2. Is it greater than equal to nums? Yes, 16 is greater than equal to not nums target. So we erase the first one. And then we got 14. Values at 0. 14, so then we can do plus equal. Another nums. So we can have 6. So it's, or 14. Yeah, this ain't working. I don't get it. I don't understand. Yeah, you know what? I solved it. I'm gonna come back to it. I'm gonna just look at solutions, or else it's gonna be here forever. Brute force. Use a hash table. Okay. You know what? I'm gonna look at the solutions and figure out better ways of doing it. How would a hash table help? You iterate through the array once and for each element. Check if the target. Oh, because we need a pair. For each element. Oh, Winston's been talking. Thanks, Winston. Sliding window is not the relevant solution. Thank you, Winston. I think my problem is I can't think in algorithms. I can only think in like the whole how to do it. Yeah, let's just follow this guy's advice. Create an empty hash, so unordered map. guess that would return a vector. Create empty hash node. Each element nums I, calculate the component by subtracting. Huh. Iterate. From left to right, for each element nums at I, calculate the complement by subtracting it from the target. Complement is equal to target minus nums I. Check if the complement is. What is the target? Oh, the actual target. How do I check if it exists? Find an element with key. So if map.find with the key, then the solution, I don't know what the solution is. I don't understand. If the complement does not exist in hash, add the current. Okay, so you should just insert because it's gonna. What does this do? Num map, and then find the index of num map does not equal I. What does that count do? Returns the number of elements. Oh, so if it's equal to 1. But they don't even insert anything in here. He also builds the hash map first. With the keys of the num. Okay, so if you do this, then you'll have an array like that, and then the positions, the key values is this. So if you're looking for the complement is equal to target at num, so let's say the target for this is a 7. we can have 7 minus 5 is equal to 2. And then we're going to count how many times 2 occurs. Or if 2 exists as a key, it does. So because it exists as a key, we know that's the solution. So then we can return I, or index at 0, and also the key itself. So map dot, I don't know how to do it, dot value at, I don't know. Well, if you do this, you would do count. If you didn't do this, then you would do insert, I believe. And we have to make sure that's not the same, like it's not 5 plus 5. Because if the target's like 10, for example, then it would be 0 and 3, not 5, so. And I does not equal to map dot at complement. What did he do? At complement. Yeah. Oh, okay, so you can do that to return as well. So you don't need to do at, you can just do at the index of that key. Which makes sense because you're adding the hash on top of it. Okay, I kind of just copied this guy's code. But should... Huh? Am I missing something? Plus n. What is an n? No. This is why. What? Oh, this is outside. Okay. Let's see. First solution, 49.73. And my memory, I beat no one now because I'm using so much. Okay, so instead of doing this, you can also just insert as we go. So like if we have 0 and 1, for example, and we insert into 0 and 1. Wait, sorry, we have 2. 7, 11, 15. Calculate the target. Oh, wait, the target complement's not in there. So, yeah, wait, I don't know how that works. Okay, you know what? I did it. Let's just keep this code. Let's start a new text document filled with all the solutions. Okay, leetcode. What? Which one? 1, 2 sum. All right. That's the first problem. And I already did. Time to do panadrome number. Is panadrome. This looks like another hash map. Let's do while x, and then we're gonna keep looping until actually, so we have a special use case. If x is less than 0, then we return false. It's always false. And we do x is equal to x remainder 10. No, we got x remainder 10, which gives us the first digit, and then I want to do it mathematically, but you can also do it as a string, I'm pretty sure. Okay, let's do converting to a string first so I can say that I can do it. So we can do dot std dot toString. I forgot what toString. We can do should give me the char at 0, and then we also need char at string length. -1, then continue. String dot length is equal to 0 and return true. Oh, and then we can do string is equal substring is equal to, is there substring? Substring S1. So let's say we have a string 1 2 2 1, char at 0 is this one, char length -1, because there's a null character in C. Is it like that? Null character, so this is -1. I don't know. I don't know if the string std string null character do not oh, okay. So we can do this one and this one. Are they equal? If they are, you continue. Okay. Take a section of that. And then this, then you continue. Or string dot length is equal to 1, because if it's equal to 1 then. Okay, run. Oops. Run. Okay, run. I forgot something. Maybe if I could just do it first. Alright, how would you do it as an int? Okay, well, I know you need the first digit and you need the last digit. So to get the last digit, you can get, once you get first digit of a number, let's see, what's this? First digit. Remove till there's only one digit left. Okay, can I do it without a loop? Oh, that's interesting. So you find the total number of digits. Log 10 it. Oh, okay, that would work. Alright. Sure, let's do it. Okay, let's run and see if this can work first. Huh? Terminate after following instance. Okay, string at string dot. Is it truly string -1? Maybe it is. Okay, yeah. All right, let's see what this time is. Or string at 0 is equal to string at string dot length -1. Yeah, that would go backwards. Okay, so you need a substring. Well, this is true, right? So we can easily just do this. Okay. Let me pass. Yay! We can do 0 milliseconds of runtime though, so. I think this toString requires it to iterate through all of it. So I'm gonna take this, find the first digit. I'm gonna do something crazy. I'm gonna do So you find the first digit of this. To, yeah, so like log 10, yeah, that gives you the first digit. And then you get the last digit, and last digit equals x remainder 10. And then while first digit is equal to last digit until the amount of digits less than 2, then return true. Let's keep our old solution in there. So does that make sense? 121. We do this log. So we get 1. X is equal to minus equal if there's 1 digit left, it's fine. If there's 0 digits left, it's fine. Let's say my number is 11. Log 10 of x is going to be 1, 10. It's fine, and it's going to be, after this, it's going to be 0. Alright, let's run it. See it working. It's magic. Okay. Remainder 10 is 0. The first digit here should be 1. It should break out of the loop. Oh. Let's do. This isn't the number of digits, is it? Log 10 of 10. Log 10 of 10 is 1. Let's just do if x is equal. Equal to 1, so it's false. What? log 10 of x. Okay, log 10 of 10 is 1, so there's 1, and my last digit's 0. And this will cast it down to 0. Either way, it's equal to 0. Okay, screw it. I tried to be cool. Just do this. If first digit is last digit, no, I think I can make this work. I'm stubborn. So let's say we have 121. You have the digit 1, and then this is 100. You extract 1, you get 1. That's not true, so we minus the power, which is 100, so we get 21. 21 divided by 10 is 2. Does that equal 0? No, we go one more loop. You have 2 here. So 2 log 10 is 0. 10, this is 1. The first digit is 0. It's 2 over 1, so this is still 2. This is also still 2. This is still true. Minus equal to power, so it's 1. Okay, that's fine. Let's do 11, so that would be 1. Power would be 10. Power 10 to the power of 1 is 10. First digit is 11 divided by, so it's 1. Last digit's also 1. That's true. Minus equal to power would give me 1. 1 divided by 10 is 0, so it would be equal to 0. I think that's good. There we go. Let's see. Runtime error. Digits equal int 10 log 10x. Negative, how did it get negative infinity? It is possible to be less than 0. Yeah, I guess log 10 of 0 is undefined. $313. This is 3. This is 3. Minus 300. So that would be 13. 1. 13 over 10 is 1. 1 log 10 of 1. Zero, 1 over 1 is 1. 1 remainder 1 is 1. Zero over 10 is 0. What? How did it pass false? Equal power. I'm confused. Why would input 313 give me the wrong solution? understand. It should. Look, it works. Maybe I should go debug. Man, I remember not being this dumb. Did I let my brain degrade? I guess so. What? G plus, I don't have G plus plus. What? How does that make sense? Why is it doing that? Okay, 3 and 3. Okay, that works. Power is 10 times to 10 to the power of 2, which is 100. So x minus 100 is 13 over 10. That's just 1. How is your num 21? My num is 21. Power is just 100. Oh. Okay, because the power is not 300. Let's calculate differently. I'm just stupid. Okay. Oh my. It processes zeros differently. There's so many edge cases. The number one. Okay. So up to this point it is, and then it does all that, and then it just makes the numbers 2. Okay, so we can just say the number of digits. So right now, you know, this is like 6, and then it goes to a one digit number. If x minus if digits is less than how do we take into account leading zeros? Use test case. The number's just 2. Okay, so C++ just truncates it. In this case, we don't want to truncate it. If x I think we should find the digits of x and see if it's 2 less than I guess I should just do this minus digits minus this is less than 2, because usually I'll have like 4 and then it goes down to 2. I forgot return false. We keep waiting. And hopefully I get better coding. This is kind of embarrassing. So digits wrong direction. Oh, it works. Give me the next one. Oh my. How am I supposed to do that? I give up. I need to move on. Bro, I actually don't know. Okay. Oh, reverse. Oh, that's much smarter than what I'm doing. Okay, whatever. We will come back. Roman to integer. Numeral number outputter. I can be placed before 5 and 10 to make 4 and 9. X can be placed before 50 and 100 to make 40 and 900. Okay, so we have some special rules. So the first thing we want to do is translate this to the value. C to 100. So if you can't simply iterate through, because let's say I have this and I'm iterating through, I would process 1 and be like, oh, that's 1, and then see that 5. Here, this direction doesn't matter. If this is 8, then I can do 5 plus 1 plus 1 plus 1, but it's because of this special thing that's not going to work. So I need a stack, I believe. Solve without solution. Oh wait, am I? Where's my screen? Easy only? Yes, I'm solving only easy. Solve without solution. That's what I've been doing. Okay. This is gonna be more of a headache. Okay, so stack. How did I do 15 of these? I must have just done like the easiest ones. Maybe I was just really smart. Okay. So then, how to get the so whatever the string is, I will go backwards. So if I get a number like this, you can take it. Does that actually help? CMX. M1000 CM. Okay, so I should write down the unique character code, I feel like. Because we have IV, IX, XL, C, XC, CD, CM. And then that equals 4, 9, 40, 90, 400, 900. Then we also have I X L C D M, which is 1, 5, 10, 50, 100, 500, 1,000. So we always look 2 characters ahead or 1 character ahead. So first we look 2 characters to see if it's IV or IX. If not, it's one of these combinations. Like VI for 6, for example. So in that case, we can just add. So 2 characters ahead of string would be substring. I can't even string to integer, I just have to do this. And make my own function. Compare. Okay, so sum plus equal if s at I, if s dot compare s at I is equal to 0, so that means it's equal, then sum plus return the values at I. Return 0. Okay, so the first thing we'll do is compare all these Roman num to int. V7 IV X L C D M. One 5 10 10 50 100 500 1000. What? Okay, so now we have the SL link. So first thing we do is substring of I to I plus 1. Then let me do minus 1 here. And then if sub count is equal to 0, then we know that it's not one of these, it's one of these. So we can do sum plus equal Roman num to int for s dot at, that's I. And else then is greater than 0, so sub plus equals sub count. And then I plus 1, so we can skip. Skip 1. So for example, if I'm here, LV is LV in here. Nope, it returns 0. Returns sum. Plus equal 1. Okay, so MC so it checks it's fine. CM is 900, so it goes this CM, and originally we count that, but now we're skipping 1s to X. Okay, should work. Plus equal return 0. Alright, let's see. Okay, thank you. Substring, not real things. Sub str though, it's real. Output 2, expected 3. Zero, 1, 2. Oh, this is already listed. Okay. Output 2013 instead of 1994. Okay, what happened? So we did M, which is 1,000, so plus 1,000. And CM is plus 100, but I'm guessing it did C. That's 900, okay. Then XC. Four. Okay, well I got the 4. I don't know how this happened. Okay, so we have some here. Sub count. A 1,000. 1,900. Okay. Why did they add 10 and then 100 though? Okay, 1,000. This is from this M. CM is 1,900. And then X is 10, so I added 10. But it should look at this and say, oh, it's XC. What is my subcount? Do they have breakpoints here? Oh. Maybe I should just do that instead. Wait, so why did it skip it? It's on 10, and then it goes I and I plus 1. Okay. Wait, what? How is this XCIV? How is it? Why is this M? This should be 2. Plus. I'm confused. Okay, 0, 1, 3, 4. Well, why is s dot substring of 3? What? That's not how substring works. 3 I and I plus 1. Why is it including more than I plus 1? Three, 0, 1, 2, 3. So 3 inclusive, okay. And 5. 3, 0, 1, 2, 3, 4, 5. Okay, that makes no sense. Spans len characters. What? Oh, it's not the same. It's not the same at all. It's not what I was expecting. Okay, this needs to be 2. 2 characters. 0 and 1. Okay. It's different from Python. Okay, it's some of it. And Java. It's also different from Java, I think. Yeah, Java is start till end too. But I guess this one is not. Anyways, 40%. 0%. Those are probably the hash map users. How can I hash map? If I initialize this to be key pair values. Yeah, okay. Let's try that really quick. I kind of just need a copy of this. And then get rid of this. I think this stays the same actually. I just need to change the functions to be a hash map. Public initialize hash map C++. Unordered map. Okay, so I can do char Roman nums. Sorry, unordered map. Map char int Roman nums is equal to I1 v5 okay. 2 3 4 5 6 7 x L C T M 1000 500 150 10. There you go. So now I don't need any of that, and now I can just say for the char at return Roman nums at C. Can ordered, unordered map have string keys? Okay, this should work. sub roaming names. This is probably one of the easiest implementations of hash map. XL, XC, CD, CM, and then the last one. 4, 9, 40, 90, 400, 900. Sub names at S. But if you can't find it, if sub names dot count at S is equal to 0, then return 0. Otherwise, return dot. Oh. Unordered map expected. Yeah, I mean, I did it like how they did it. So if we do this, so 4, 5, 6, 1, 2, 3, 4, 5, 6, 7. Okay. Yeah, that should be fine. I forgot a comma there. comma. There, I forgot a comma there too. Multi-character constant. IV, IX, XL, XC, CD, DM. That should work now. 2194. Unordered. Output amps. right now this is always returning 0, I believe. Zero 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 904. So we have M, which gives me 1,000. Then CM. Wait, CM. Why is this DM? It's not thing. Okay, CM. Okay, there you go. Yeah, that's what I thought. Okay. Submit. Okay, it got way worse. How did that happen? Leaving 2 characters at a time. Okay, well, that's my solution. It's just this. Next. Okay, I gotta solve these faster. I'm just gonna accept the first one, solution. Longest common prefix. There's no longest common prefix. So for all of them, only lowercase. So it's just the beginning. Okay, so I can just do for int I equals 0, I less than strings dot length. So we have a few cases. Like let's say your list is just this, then that would be perfect. But let's say it's this. Then you have pref. And then you just have pre, so you can just end one substring. So we can produce a substring. String my sub for I till be 1 at first. If length of prefix is greater than 1, greater than we don't know how this long is, so we should do well. This should be the condition. So while my substring j dot substring. You can do well. So for everything in the loop, we can do string doesn't really matter what I start with, right? Because it has to be common for everyone. So I'm going to start with 0. We don't really need to do that actually, we can just do length of prefix. Now we can do if common substring dot compare at all strs at j dot substring of zero to length of prefix. And these will all be true. True, true, true. So if it's false, return common substring. If not, it's gonna keep going. Alright. Let's see. Okay, you can't return null. We'll just return an empty string. Should all be true, right? Okay, I need the first case too, as well. We need to have to return substring j dot substring of 0. which is false. Compare equal to 0. Oh, right, it's equal to 0. Okay, so this is gonna pass the first one now and fail the second one, because the second one oh, actually, this would fix that. How did it get to 2? Okay, I forgot to do this. It wasn't comparing itself to anything except itself. I keep forgetting edge cases. Return false, length, size. All characters. What? How did that happen? I didn't change anything except that. That's just an empty string. Please let me pass. How? This is size equal 1, right? That's why. Okay. Empty if strings dot size is equal to 1, just return strings at 0. Okay, now do your work. Length of prefix is equal to I love this use test case button. I think it has to be this, -1. Length. Six, 2, 6, 3, 6, 4, 6, 5, 6. Then I should do. Oh, I see. Okay, Flowey. Because it's inclusive. A, B, A. I need another if. If the length of the prefix is greater than this, then I want to return this. If length prefix is greater than, does that work? I didn't even return. Okay, yeah, so this takes into account if one of them is shorter than the other one. This takes into account if they're the same length as all of them. Okay. Please pass everything. Why is the output A? Length is 1. It's this one. And does not equal 1. Lots of edge cases. So in this case, we have one iteration, so this is equal to 1. Then this is A. So is 1 greater than 1? No. But what? 1. No, because I want this statement to run. AB, so is length is 1. Is 1 greater than 2? No. Is 1 equal to this length? Is 1 equal to? No. Oh, this isn't even true, so this can't even run. So it should run this one. Greater than strings dot length. Is this even doing anything? Nope. The answer was no. Okay. So do you get rid of this S? Why don't I get the max? Listen. So get the length of that. Boom. I should fix both of them, but maybe not that one. What if I got min length? I'll give this like a high number. Okay, We're cooking. We're cooking. This one has 2. Question is killing me. Okay, now I'm not even right on the first one. Okay. I think this one goes after this. Okay, well now okay, so that equals max length, no return, because it's at the max. But then this isn't even the same. It has to actually equal if you want to return that one. And this one, return that minus 1. I don't know if any of these statements make sense, so I'm just going to remove them. Put them down here for now. What's the pattern? Okay, we definitely need this one. If the length of the prefix is equal to the max length, then they're all equal. Okay, there we go. But then here's the last one. They're all equal. But this isn't true. Okay, they're all equal. Compared all equal true. So only if we compare it all. Only if we compare it all, then this works. J. Yeah. We're so slow. Okay, that's fine. I think it's this min size that makes it slow. It's max length. So let me get rid of this. And then we can just say the max length is think about it, the max length can just be whatever the first one is, because there will be no minimum. Alright, let's try it. Is nice. It's slower somehow after I removed it. No, we don't have to access that one property. Okay. I'm getting slightly faster. Okay, I don't care anymore. This is my solution. I think if I want to optimize it, you can get the first character and put in the hash, and then keep on checking if it exists or not. Okay. Valid parentheses. This I need stack. Char. Then we can pop for every. Okay, how many types of brackets are okay? Stack. So we just want to say if empty, return stack dot empty. For I equals 0, I is less than length I plus plus stack dot empty. We can do if s at I is equal to any of these. Is at j push beginning parentheses at j and ending parentheses. Doesn't matter, we can just pop. So for example, if we have this, then we'll push our step will do this. We push this, then we pop. Okay, cool. Push this, then we pop once, then push this, pop once, then push this, and pop once. Push this. Oh, yeah. Okay, we can only pop. You can only pop if the parentheses aren't the same. How do we say? How do I correspond this one to that? SHRI. So let's say it's like one of these. Yeah, because it closes technically, but it's just a different parentheses. So how do I do it so that if stack dot, I should look at the top. How do I look at the top? Peak. It's dot top. Okay, so dot top. There's no pattern to it. Dot top. How do I associate? I wanted to use ASCII, but it's if it's the top two, then it's one space apart. But if it's the bottom, if it's these two, it's two spaces apart. So that doesn't work. Oh, I can do. There, so they have to be equal. Okay. What was wrong? Segv. stack. What is this? This fault was caused by a dereference of a high value address. Oh, in case it's null. Alright, well, we can just do this. There we go. Please work. Oh, I can just do... My stack is not empty. Wait, what? I'm confused. How? It only pushes onto here, so this should be false because... Oh, it would be... Stack is not empty. Okay, so what's happening is the stack is still empty, but there is supposed to be, there's no other parenthesis, so that doesn't do anything, and then it just goes to the end. So technically you can have as many end parentheses as possible. And then that doesn't solve anything though. If this is equal to n parentheses and your stack is empty, then it's wrong. Actually, I don't need that then, I don't think. Because that just means you can't go backwards. Oh! Okay. Wait, this should be false. My stack dot empty. Okay, so you push this first, push, so it's on top of my stack. These don't trigger because it's not next. Okay. This never triggers, but push and parentheses for this one, so j is equal to 2. Yes, but my stack, the empty. Oh, so it's I mean, it's still wrong. That just means it's a loose. The stack is empty. Okay, so what if we're not empty, but it's an ending parenthesis? Well, if the top isn't the same beginning parenthesis, then it's also false. And it's not empty. There we go. What? 100%? Oh, 81 point. Okay. Alright, perfect. Okay, cool. This is the best solution I've ever had. 20. Merge to sorted list. This one's actually not that bad, so list 2 is equal to no pointer, return false, false, and all my logic can be here. So we need a new list, so list no. So we can determine which one's the least, then we can do a while loop to keep on inserting the next. So the structure should be the same, but we can keep inserting. Next. Okay, so we got the heads, so wow. List 1 is not empty, it's not equal to no pointer. No need to make a new. List 2 is not equal to no pointer. If pretty much this, so if list 1 val is greater than list 2, so I can just take this logic and put up here. So I need this to be I do need to instantiate this. head. So let's say for this example, we got 1, 2, 4, 1, 3, 4. So we got 1. That's not equal, so it doesn't matter. We can do head is equal to list 2. So our new head is 1. List 2, so list 1, 1, 2, 4. List 2 is 1, 3, 4. So, but this got removed. Because the new head's equal to that. Then we got iterator. 1. So then list 1 val is greater than list 2 val. So if list 1 val, 1 is greater than list 2 val, 1 is greater than 3. Oh, this needs to be less than, because we're sorting it. If 1 is less than 3, it is. Then iterators next is equal to list 1. And then list 1 is equal to list 1 next. That gets transferred there. Then we delete it. Yeah, I think that works. Why am I missing a number? New head val. Okay, why is it not doing the last one? Okay, let's run it together. List 1, 1, 2, 4. Man, I can't believe I'm so washed. I don't know, it doesn't matter. I think take some list 2. 1. Head stays here though, so not no pointer. Okay, list val less than. Oh, this should be or. Okay, we'll figure it out. Yeah. Iterator does not equal null pointer. Bruh. I feel like this shouldn't be that hard. Okay. Anyways, back to what we were doing before. So, nope, not null pointer. So the moment both of these equal null pointer, we'll stop. This one val is less than list 2. Yep, that's true. So iterators next is equal to list 1, which updates new head automatically. List 1 is next itself. Okay, cool. Iterators next. List 1 val is less than list 2. 2 is less than 3. That's true. Iterators next is list 1. Yeah, that's already true. List 1 is next. This is next. Okay. List and val, that's false. List 2 is not null pointer. That's good. Iterators next is list 2. That updates this one. List 2 is next is here. And iterator is next as well. So I'll take this one. Next is 4. That's 4. And then iterators next is null pointer. Okay, iterators. Yeah, okay, so this is next. Okay, anyways, I'm on this 3. So we got 4, 4 left. So yeah, and then iterate is next. So we got 4. Doesn't matter, but it takes from us 2. That's 4. That just so happens to be there. And list 2 is next. It's the pointer. Go next. So the last one we have is 4. Does not equal null pointer. To avoid dereference. Okay, let's do this again. So 1, 2, 4. 1, 3, 4. Okay, iterator's the same. Okay, so now we're looking at the next instead. Wait, why don't I just... If list 1 is equal to null pointer, then iterator next is equal to list 2. If list 1 is equal to, if list 2 is equal to null pointer, no, we have to return after that. List 1 next. I swear I'm like 90% sure there's a better way of doing it, because I remember doing it better way. Whatever. We did it. I finished 6 in 3 hours. This is not how fast I thought I would do. Man, I actually suck. Remove duplicates. Dude, I literally wrote the test program to remove duplicates. Vector, okay. Nums in non-decreasing order. Okay, nums. So it's increasing, non-decreasing. Duplicates in place such that each unique element appears only once. The relative order of the... Okay. So this is pass by reference, so whatever I do to nums will change. Change the array nums such that the first k elements of nums contain okay, so for like this, for example, k is 1, 2, 3, 4. And then probably just have an iterator. And then you keep going till it's the same, so we need a previous number. And we need k. So the previous number is 1. So if the nums at I is equal to prev number, first occurrence equal false. First occurrence could also so if the first number is equal to the previous number, then k plus equal 1 first. So we can k plus 1 because it appeared. Yay! First occurrence is true. Cool. And then we can also add to new nums push back okay, then we loop again, so we got 2, so the previous number is 1. So we have to reset it now, so else the previous number is not equal to that. The first occurrence is equal to true, Because it first occurred. Previous number is 1. I feel like I'm doing this wrong. Let's just always do this. And then this. If previous num does not equal nums at I currently, the first occurrence equal true. I probably want to do this. If previous nums does not equal I feel like my brain hurts from not being smart. Okay, I'm gonna pause and eat food and live life, and then I'll come back. Maybe. If I feel like it. I can't believe I only did 6. I suck. Alright, bye.